All right, so our last two examples. Okay, you can see that in this next example, we do not have the equation in y equals mx plus b. So that is our first task, is to get that, actually both equations into that form. So let's do both equations first. So I'm going to subtract x from both sides. And so I end up with negative y equals negative x minus 5. I need to multiply everything here by negative 1. So I get y equals positive x plus 5. Now from that information, I know my slope is 1 and my y-intercept is 5. Okay, and let's go down and do the next one. The next one, I'm going to subtract 2x from both sides. And I end up with y equals negative 2x minus 1. So in this case, my slope is negative 2, and my y-intercept is negative 1. So back to the first question. Okay, so we're going to graph, actually first equation, same question. I'm going to graph 5 on the y-intercept, and the slope's 1. So it means I have to rise 1, run 1, rise, run, rise 1. Okay, and so you can see we have our lovely little equation line, and now we're going to draw a line through it, and we'll make it blue. And actually, if we make it thinner, it might be a little bit easier to see where something intersects. Okay, again, because I don't know where on the coordinate grid they will intersect, I need to make sure I expand my line. So that was one reason too why I told you to make sure your lines just don't join the points that you've drawn. Okay, the next thing I'm going to do is draw the next one after we actually put that this one is that equation, which was x minus y equals negative 5. You could use that equation, or you could use the converted equation of y equals mx plus b. So this one, either one will work. Okay, the next one we're going to choose green, and oops, that again. So in this case, we have the y-intercept is at negative 1 this time. So down the y-axis to negative 1. Then we go down 2 over 1, down 2 over 1, okay, down 2 over 1. So we can see that they're going to intersect in the second quadrant. And let's turn that green. And let's get this one graphed. Okay, so that's pretty close there. And we'll write down that equation so that if someone looks at our work, they know which line is which. So we had green, so that was 2x plus y equals negative 1. We can see their point of intersection occurs right here, which is the coordinate negative 2, positive 3. And we do our therefore statement. So therefore, the solution is negative 2, 3. Or negative 2, 3 is the solution, same thing. All right, one more example. Okay, so neither one of these is in the correct form. Some of you maybe, if you look at those equations carefully, you might notice something about them, but maybe you don't yet, and that's fine. So let's take a look at this one. Okay, so the first thing I'm going to do is I'm going to subtract x from both sides, and when I do that, I end up with y equals negative x plus 3. This next one, I'm going to subtract 3x from both sides, and that would be 3y equals negative 3x plus 9. Then we need to divide everything by 3. and we end up with y equals negative x, negative 3 divided by 3, and 9 divided by 3 would be a 3. Now you should definitely see something between this equation and this one. Guess what? They're the same. They're exactly the same. But if you notice what we started with, they look so different. Okay, so these ones, what's going to happen here? They're going to intersect everywhere, right? Because they're the exact same solution. So in this case, you could draw both lines if you want, but once you see that both signs are identical, then you can say both lines are identical. And what does that mean? Therefore, infinite solutions. Now, so if you discover that they are identical, the answer is infinite solutions. Now, I also have some stars here, and that's because of one other thing that you should know is if you recognize that slopes are the same, and we talked about that in a couple lessons ago, it means they never do intersect. So if you recognize even before you graph that two lines have the identical slope, then you can say that there are no solutions because the lines are parallel. So we're going to write that down in our notes as well so that we have that for future reference in case you come across that. If the lines have the same slope, they will never intersect. The solution, the answer is then no solution. Okay, so it is possible that that happens as well. And actually, if you can recognize it, it actually saves you having to graph two lines. Okay, but that's not a whole lot either because you guys are so good at it now. Okay, so there's your last lesson of this unit.